Question 4. A sports car is bought new for £725,000. When the car has been used for 1 year, it is worth £600,000. The owner decides to use a linear model to predict the value of the car, using T as the number of years she owned the car and V as the value of the sports car. Key thing here is that she's using a linear model, so let's think that implies that V must be equal to A, where A is just some constant, plus B, where B is another constant, T. And we've been told that V is equal to 725,000 when T equals 0, and we also know that V is equal to 600,000 when T equals 1. From this information, we can work out the gradient. So the gradient is going to be 725,000 minus 600,000 divided by 0 minus 1. And so that's the gradient. And that's going to be minus 125,000. In our looking back at our model, V is equal to A plus BT. Our gradient is going to be our value of B. And this is a linear model, so A is going to be our y-intercept. Our y-intercept is when T is equal to 0, and we already know that V is equal to 725,000 at this point. So we can sub that into our y-intercept, and so giving us V is equal to 725,000 minus 125,000 T. And that's our equation for V in terms of T. Part B says use this equation to predict the value of the car after 3.6 years. So we know that in this case, T is equal to 3.6. So let's sub that in. And this gives us 275,000. Part C says comment on the suitability of the model. If we think about it, this is a straight line with a negative gradient, a positive y-intercept but negative gradient, and so eventually as T increases, this suggests that the value of the car will become negative, and we know that's not possible. So this is not suitable for large values of T. Suggest an improvement for the model? Well, maybe it'd be better if the value of the car tailed off in the long run.